zero energy design, digital fabrication, and circular components and materials are just a few topics you can explore within building technology at TU Delft. Imagining and inventing the future built environment is what this master track is all about. At the intersection of architecture and technology, this unique hands-on programme blends research, engineering and design to shape the sustainable designer of the future. What does it mean to be a part of this programme, who's it for, and where will you work? Let's get some answers from the people involved, starting with Master Coordinator Peter Thayer. Peter, can you tell us more?
Yes, of course. We notice in practice a great demand for architects, designers and engineers who understand each other's areas, who can innovate and who know how to design sustainably. You could say there are engineers and there are architects, but who fills the gap? This track is what sits in between. We aim for graduates that can bridge design and engineering. There are designers and engineers embodied in one, like structural designers, facade designers, climate designers, computational designers and sustainability designers. Innovation is what drives us. Within the various and diverse fields, we focus on developing new ways to build, being able to understand complex problems in order to create an innovative, future-oriented and sustainable built environment, making architects' dreams come true.
Thank you, Peter. Making those dreams a reality is no simple task, especially with the many challenges designers aim to tackle today. If we head over to the Green Village, TU Delft's very own field lab, we can find our resident expert in sustainability, Professor Andy van den Dobbelstein. Can you tell us more about the problems addressed within the master track, Andy?
Humanity faces a lot of challenges related to a healthy, sustainable built environment. In order to be ready for 2050, the built environment needs to be carbon neutral, climate adaptive, circular in its use of building materials and contributing to health and biodiversity. At Building Technology, we teach students how to do that, how to become the sustainable innovators of the future. And here at the Green Village, we test these concepts. Behind me, you see a part of an office tower that was refurbished to a circular new apartment block, and here at the Green Village we also test climate adaptation solutions that relate to rainfall and heat. The special quality of building technology is that we teach students how to conceive, design, engineer and also construct the solutions they imagine. And that makes us stand out among the other master programs.
There's certainly a lot on our plate. Now we know what drives us, let's find out what the role of the building technologist or architectural engineer is in the building process. Professor Ulrich Nark has some answers for us.
Architecture engineering is about the making of the details, the materials, the choice of technologies. There's all this technology which needs to be integrated into the design, and we as architects, next to the, beauty of the design, we have to make technically feasible buildings which function. How do we do this? We need to think about the structural design, the load-bearing structure. We need to think about the building envelope. Here I'm an expert. We need to think about all the services in the building, the climate design of the building, and we need to think about the material. First, understanding how systems work. How does a brick work? How do you staple bricks? How do you create solid structures? How does a column work? How does a beam work? What's the difference between wood and concrete in this respect? Then we experiment with these components and then we do prototyping with these components. Prototyping in the means of this building. This building is an entire experiment where we designed, engineered details with a new type of material to identify how well does it work, where are the complicated parts, how are the problems, and how does it look like? How does it become a nice design? Which brings me to this word of the integral design, the total design. We are aware of the pain an architect has in design processes. All the aspects which need to find a compromise, which need to be brought together in the final design, of which the details are part of. We are dealing with the structural engineers, with the climate design engineers, with circularity, with the building envelopes, and that all has to compromise in this final integral detail.
Thanks for your insight, Uli. A building technologist is a pragmatic dreamer that becomes an expert in navigating contrasting perspectives and goals. How do you learn to do this? Let's take a look at how the 2-year educational programme is structured. Back to you, Peter.
In the Master 1 design course, we start at the product level on a small scale. followed by the building level and then addressing the urban context. The design courses are supported by a large range of courses that provide the needed knowledge and skills. In the graduation phase, you choose your own topic, which can be on all scales. We focus on 4 fields: climate design, facade and product design, structural design and design informatics. The graduation projects always include at least 2 of these fields. As you may have noticed, we love to experiment, work with our hands and build. Directly from the start on, we do this in the Bucky Lab.
The Bucky Lab is a mobile design workshop and one of the courses within the Master Track. Let's head to the workshop to find its pioneer, Marcel Bilo.
Welcome to our workshop. Right now we are running the building weeks of the Bucky Lab, our first semester's design course. In the course we design, engineer and at the end build innovative concepts of building products. The full-scale prototypes will help us to test the ideas and see what works and what not. And it's also the best way to see if your drawings are correct. Sometimes they are not, but failure is always an option. And we create an environment in which you are able to learn from your own mistakes. This winter we work on convertible urban sunshades. It's a rather new concept. Think about shading our streets and squares to reduce the heat island effect. At night it has to be opened to cool down, and that's a tricky task. And the reason you can see so many mechanical parts and solutions here in the shop. They all have to deal with opening and closing of these shades. Over the years we have developed many ideas like sunshades that create energy, green facades or even refugee shelters. And often we do this with industrial partners.
Fantastic! And what can students expect to be doing alongside this?
Next to the design course, the semester also has additional courses like computational design, material science, structural mechanics and climate design. It's a busy first semester, but fun to learn so many different skills and also the time to make new friends. Nadia, did I miss something?
Actually, yes. Next to these tools, we also teach you the soft tools. In research methodologies, you'll learn to develop your mind with tools, methods, and literature studies. We teach you to present your ideas, both in short, concise elevator pitches and longer, captivating presentations. And what fascinates me in this track is a perfect balance between male and female students and international and Dutch students. I'd say both are a good 50-50. Now, in this movie, you've seen a lot of men, but let me assure you, there is plenty of talented female colleagues in this track.
That's exciting to hear. Thank you, Nadia. The Bucky Lab is just one of many workshops within the track. This hands-on approach is a defining characteristic of the programme. Students have access to many specialised labs and tools. The Sense Lab helps students explore climate and comfort design. The Robotics Lab Llama offers experiences with 3D printers and robots, while workshops in computational design explore topics like artificial intelligence, data-driven design, and advanced simulations. The Building Physics Lab teaches students how to use a range of measurement tools, and the Glass Lab allows research and education into the field of glass. This programme is ideal for both designers looking to strengthen their technical skills, as for engineers looking to strengthen their design skills. Graduates are designers and engineers in one, able to contribute to buildings that are sustainable, comfortable, and environmentally intelligent. Building technology graduates are in high demand, as the construction industry is lacking designers that bridge this gap between the architectural and engineering disciplines. Is this true, Peter?
Graduates are really wanted in practice. Sometimes students are even picked up by companies before graduating. Our alumni can expect to find generalist and specialist positions in engineering offices for consultancy, in the larger architectural firms, also by specialized facade companies or in the industry. Others start their own company or continue further studies as a PhD student for an academic career. Have a look at our website. Here we share videos of our alumni who works in many different disciplines and companies. You can also contact our student association, BOUT, for information about the study.
Thanks for wrapping up, Peter. If this sounds like something for you, then you can find out more by attending one of our master events and, like Peter said, visiting our website and study association, BOUT.